Okay, hello good people and bad dogs. Not directed at anyone in particular. Alright, microphone is working and camera is working. So, we are live and the title of the stream, I need to check it because every time I change it, there's like a 50% chance it doesn't actually change. So maybe I want to check, that. Compiler live coding. We're good on YouTube. We're good on Twitch. We're good on both. Okay. All right. Not sure why Steam is open, but today I got a lot to do, and I've done a lot. So I gotta show that off. And I got a lot to plan. I have a lot of exciting things planned for the weekend. Exciting being a strong word here. Whenever a programmer says that they have something exciting or fun going on, it's a relative term, all right? But I do have some plans. Hi, Penguin. I learned how to navigate. First off, I have a new keyboard, and I'm not 100% used to it yet. But hey, listen how nice it sounds. I don't know if you can hear it. Yeah, maybe if I speak, you can hear it. Like that. So much nicer than my previous one. And, wait. Look what happens when I press the top right button of my keyboard. Nothing. It doesn't open a calculator. It doesn't open a calculator. Isn't that just incredible? I think this is the best thing that has happened to my computer since I don't know, in a while, since I got Linux on it. Yeah. All right. Let me see what I got going on. So today I'm doing some compiler stuff. Blender. Okay. I was wondering what this file was. It was Blender. All right. I've added a lot of new features to my compiler to the point that it even has some of its own code running. It's partially self-hosted, I guess you could say. It's a relative term because it compiles to C, so it's a relative term. But hey, it took like 3 weeks to get here, okay? So 3 weekends and this week, pretty much. So not half bad, I would say. That was my first compiler stream like 3 weeks ago, I think. And 3 weeks ago, yeah. So considering how little it's been, it's already pretty fast. But again, it's because it compiles to C. But I can already compile, first off, my build system configuration file, which I kind of rewrote my build system to work in this way, to be configurable through code instead of through a TOML file, which was always the goal, but, you know, I wasn't quite there yet. Now it is. And I guess you can do it in a somewhat declarative way, like rule gen, C, and compiler are 3 different sub-projects or 3 different compilation steps as part of my whole compiler, as part of the whole build system for this project. It's kind of making me dislike putting the return type here. I'm starting to understand why languages can do it like this, for example. I'm not sure yet. I'm not sure if this is what I want. But my entire compiler, you can change the syntax of the whole thing with just a text file. It's getting quite long, but hey, text file. So if I want to have function declarations like that, I can just do that. It's that easy. Hey, Yasake. That's the first part that is somewhat self-hosted. That's the build system is technically not part of the compiler. Also, the way that it works is kind of like you have to compile the build command because it's actually just an executable. Yeah, I don't like that part, but uh, we'll take some time. Eventually, I'll probably use this language for my scripting language for my terminal at the very least. So most likely I'll have to make it interpreted, and then it'll be a lot easier to do build system, but I'm not in a hurry to do that. That's the first part of the compiler that's quote unquote self-hosted. The second part is I was using some enums to define um, the different like parts of the different statements and different operations that you can do in code to generate an internal intermediate representation of the code that I can then do work of. And those enums are now compiled by this enum file, which means my language also has enum support now. Forgetting the word here. Yeah, Clang sees errors where there really aren't any because these are technically keywords. You shouldn't really use them, but these are like semrule for semrule while semrule enum, so on parent and else. So it's not too much of an issue. But yeah, Clang has some issues with it, but it compiles just fine. And these enums get compiled to these semantic rules.h and .c. So it gets compiled to this enum. And it has a function to translate it to a string. And then, well, yeah, that's about it for the code that's actually in the compiler at this point, that is run by its own language. Throughout the process, breaking the compiler like a bug was a tragic thing because it means that, you know, you can no longer compile your fixes. So you have to be very careful. But actually, all the files that I just mentioned that get compiled from my language get compiled to C. So if it breaks, you just compile the C files directly. Have to keep a bootstrap compiler around. Yeah, that's why it compiles to C. So, for example, when my build system broke, all I did was just compile the build.c file, which is generated from the build.redb file. So yeah, worst case scenario, you do that. Or if it cannot handle some particular niche rule correctly, then you just do it like that. And actually, in order to compile the build system, because again, it needs compilation, the tool that does it, redc, has you can pass a C option to it, and then it just compiles the C file without recompiling the cred file. So it skips that step if that's what you need. So yeah, it's somewhat able to, well, it is able to bootstrap. At this early level, it's very common that it will break. And actually, what led me to like including these C files, because they were actually getting ignored, the build.c and actually the output file that I use for testing. This one's not important, it's just used for testing. What led me to actually committing them is that I was writing a README file for the build system, and I was including like the steps that you need in order to use it. And I was like, you need the compiler. Wait, the compiler relies on the build system. So you need the build system for the compiler and a compiler for the build system. Yeah, that's a problem. So I include the build.c based on the latest changes that I made to it, and you can compile with this without redb. So the only dependency that you have is GCC. The other thing that I kind of somewhat generate with my code is this CodeGen T interface, and one of the structs, this one I actually just added, you can see here, I literally added it, I haven't done anything with it. But sometimes Very few times, but sometimes parent classes are important. There's use cases for them. For example, when you have multiple objects that are different, but they have the exact same behavior, well, not the exact same behavior, but the exact same interface. Um, you can use object-oriented programming. So I added interfaces to my system, right? And just to keep this code here to illustrate, this interface, what it does is it translates to this. It just keeps a pointer. It keeps track of the type that it is, so the subclass that conforms to the interface, if you will. I'm not sure I'm going to use this field. Right now, it's not being used. Keep in mind, all of this is supposed to replace code that I wrote by hand that I'm already using, this one. And I'm not using the type field for anything. It's just there because it was already there in the handwritten code. So might as well. But yeah, this can technically already replace that. I just haven't gotten around to it. And then there's all of these structures that conform to the interface. They conform to the interface in the sense that they create an init file that returns that interface, which again is just a virtual table essentially. They have a struct that defines their properties but not their functions. And then internally, they have their own version of those functions, and they create an object of the interface type with function pointers to their own functions. And then the interface class just calls the function pointer. That's already how it works in my code. It's just handwritten C, as opposed to this one, which is generated from cred code, which is a lot simpler because you don't have to write all of the boilerplate for it. I would love to do interfaces without function pointers, but honestly, I haven't even begun to think about how I could do that. I just cannot be bothered. But this is kind of the thing that I want to talk about today. Let me see if it actually does it. I'm going to talk about what we're going to do today, but then I also want to talk about what I want to do the rest of the days. Can you say space by storing the type and then just calling the pointer out of some static array? Considering their interfaces, maybe. What is that, like 8 bytes per function? It's not a lot. We can afford it. We can afford it. If anything, I would. Well, that's a lot of stuff that just fell off my desk, including a hard drive. Cool. Have SSDs gone up in price? I heard that that was happening, but I'm not sure if that's happened. I should probably take better care of this thing now. Let me see if I can compile. Okay, yeah. So I want to talk about what I want to do today, and then I want to talk about what I want to do the rest of the weekend and the other times. Prices up. Oh, I'll check it out in a second. But let's try to compile this file, which is codegen.cred into codegen. Ah, damn it. I compiled it into this one, not this one. Ugh. That's my bad. But anyway, this, you can see, looks very similar to the original code that was there. The difference is that these functions didn't have the codegen t prefix, so big deal. Next is PSU. I don't think they're using traditional PSUs, but maybe the components that are used to make them. There's some spacing is a little bit iffy. So for example, it adds space here that it shouldn't. Big deal. And then again, it changed the name of the functions. It used to be register element. Now it's codegen register element, but it's the same thing. It's the same thing. But didn't I? No, I didn't. I didn't save the change that I made. So what I was gonna explain, I'm not able to. Oh. Yeah, I don't think you can handle this. Can no, wait, that's not it. Syntax error on line 13. Oh, I forgot the semicolons. Hold on. That's the problem. Alright, no, it can handle it. Okay. I made some changes to the way that it outputs files because now it outputs to an H and C files. So I was worried that because I was using this as an output, it was having issues, but no, it was an actual syntax error. Also, yeah, when you specify output codegen/codegen without an extension, it generates a .h and .c file. When you specify an extension, it generates into that file specifically. And when you generate into two, it splits the code. So here you have, for example, the type defs. This one doesn't have any properties, so you can see it doesn't include any properties, but it has a bunch of extra space. Again, small little formatting things. It declares the functions so that you can use them, but doesn't actually implement them, and then the C file implements them. However, this is where the problem comes in. BLK code is an interface conforming type to codegen_t. That means it has a register lm function, a register subrule function, and an emit code function. And it means that it has a init function that generates a codegen_t structure type. And then by calling one of these functions, passing that type, you can call these functions, as opposed to those of another subclass. The problem is in generating that init function. First off, it's not generating the BLK code functions in here, but that's probably just a small bug, or I just intentionally kept them out. I don't even remember what it is. But we're supposed to create code that looks like this. Right, we have to allocate a function, a pointer. So we allocate some space for the BLK code structure, which is actually empty, so that probably allocates nothing. I actually don't know how that would work. Does it say? No, not really. But then we're supposed to populate the function pointers. And we know what functions are part of the structure as we're generating the structure, so we could do that. The problem is I specifically added a helper function to it. This helper function is part of BLK code, but it's not part of the interface. And if I just generated the function names naively, it would also try to generate a register lm, subrule, emit code, and a helper function, where the helper function doesn't actually exist. So that would generate code that is wrong. As opposed to now, which is just generates code that is commented out. So it generates a warning, but not an error. It's also not usable. And there is also other code with the same name, so it will conflict. But yeah, before I can generate that code properly, I need to do some semantic analysis lookup. I need to look at, I could have already do it with a hack, but ideally we do it correctly. So I waited until today so we could do it on stream. Essentially, what we're supposed to do is when we're generating the structure, we're like, oh, it's a child of codegen. So that interface, we need to look at what functions the interface has. And we should check that it implements all of them. Maybe we can skip that part for now, whatever. Maybe not. I am skipping any like symbol resolution for now because certain things like the true keyword, for example, it doesn't know what they are, which is another thing that I want to do today. That and like functions and variables that are declared in C or in another file, it doesn't detect them. So for the time being, it's easier for me to just skip all that. If you have a variable, if you're using a variable that doesn't actually exist, GCC will tell you about it. I won't. Well, I will, but I'll continue to work. Yeah, so the way that it should work properly is that in order to generate this, it should know its parent, look at the symbol table for its parent, see what it declares, see like, oh, it has three functions, and it has this type. And then check, do I have the type that I need? Do I have the functions that I need? And then generate this code based off of that information. That way, it will generate the proper code. And for example, this helper function that isn't actually part of the interface won't get added to the interface, which would create an error. We don't have that right now, so we're going to reset this code back to the way that it was. And so that's what I want to do today. I want to do proper semantic analysis because I am collecting a symbol table, but there's no such thing as a scope. There's no such thing as correctness. So, oh, pragma ones. I'm kind of forgetting these in the header files. I probably need to generate those. They're always useful. Let me do that before I forget, and then talk about what else I want to do this weekend, and kind of in the future actually, because the compiler is already in a place where it's doing pretty well. I've been able to add a lot of things to it without having to add any new functionality to it, just by altering the rules and a little bit of code fixing and format fixing here and there. Let me see. I already said it has enums, it has interfaces and structures that conform to the interfaces. It also has structures that don't conform to any interfaces. Well, you can have that. I added defers. I added else's to the ifs just today. I already had loops working. Parentheses work properly. So if we look at the generated code for this, it actually generates the parentheses correctly, which it didn't before, and that could lead to issues. Array indexing works correctly. Also, the code is just insanely meaningless because it's just test. I just tried to cram the entire syntax of my language into one file, pretty much, and I don't care if the functions that I'm calling are real. But Clang kind of does, so it just like spits out a bunch of errors because I'm returning with a void here. Okay. Yeah, so it has the fur, which used to be here. Now it just prints out this empty space, but it ends up here at the end. It used to do the fur cleanup and then the fur x equals 0. And then if you encounter a return after the defer, what it does is it keeps a return value somewhere, assigns to it, and then goes to defer, does the cleanup, and then returns it. So that's kind of how I handle deferring. You can defer with a block. Where are we? You can defer with a block, or you can just defer with one statement. What other features did I add? I haven't removed labels and go-tos yet, which the generated code will have go-tos and labels, like the defer one. And yeah, I think that's the only one that, as far as I can think of off the top of my head, will need labels and go-tos, but I don't want them in the actual language themselves. So now that I have proper loops and proper function calls, I don't need those anymore. Yeah, I did a bunch of fixes to the expressions because they were kind of like buggy as hell. Now you can write this type of syntax, even though it's completely meaningless because y is an integer. Again, don't look at the meaning of the code. I was watching a video that was calling back to that one guy that got arrested after eating a succulent Chinese meal, and that's why I printed out "This is democracy," by the way. I just realized that's actually there. So, what else did I add? I feel like there's more stuff. Like I said, else statements, the first returns. The returns weren't actually there last time, so yeah, I added those. Now I pretty much have all these rules. and made a lot of fixes to the expressions, to variables, enums, structs, uh, structures, returns, interfaces, and defers. That should be about it in terms of stuff that I added. I added also an include C, which I use in the build system to tell it what header files from C to include. So I don't want my project to need to include stuff. I haven't really thought that much about it yet. But right now, if you try to compile multiple files, it just like strings them together and then compiles them as a whole. So kind of what C does with header files, but I do it with the code directly. For now, it's fine because I compile one file at a time, so I don't really care. Okay, those are the changes that I've made to the compiler, and today we're going to work on the semantic analysis so I can finish adding interfaces. I can also add a few other things that are missing, like string literals. Technically, you can have a string literal, but I don't have a type for them. That's the kind of weird thing about it. Technically, this is allowed. This should compile just fine, I believe. Yeah, it compiles. But then, obviously, C has a problem with that. The thing is that I don't have anything to call my string literals. I was thinking of just calling them literal, or even just like string. Although maybe I want to make, at the very least at the beginning, I want to make a distinction between a string, a C string, and a string slice, which is the one that I want my language to mostly rely on, which explicitly delimits where the string starts and ends. C strings are ended whenever you encounter a null byte, essentially, which is not ideal. But yeah, with semantic analysis, I'll be able to do something like literal to specify a C string, and then with semantic analysis, it'll be able to be like, oh, okay, a literal. What's that called in C? A char pointer. Okay, so I'm outputting char pointer instead of literal. So it should do that kind of translation, which it currently cannot do. Which means that any types that I use have to have the exact same name that they have on C. Or at the very least in my header, which is, you know, uint32 underscore t and stuff like that. Whereas I would rather use like i32, u32 actually in that case. Hey Arctic. So yeah, with semantic analysis, we'll be able to do a few more of these things. But again, most of the changes that I just added, structures, all of that stuff. Oh, you're in both chats. I'm doing good. How are you? Most of it hasn't required any kind of like super flashy development. It's mostly just been very repetitive. Change these rules, add new semantic rules, add new code generation rules, and that's it. So generating some of this boilerplate code is about all I've needed to do. And a little bit of bug fixing here and there. But it isn't super exciting, right? And after today, hopefully, I'll be able to continue with the new features that we built today. And it also probably won't be super exciting. It'll be quite repetitive. So it will probably happen off stream, but I'll start using the language once it's ready enough to be used more and more. But that leads me to the other thing that I was going to talk about, which is other projects that I want to work on. So today, I want to work on semantic analysis for the compiler. Then, these four things are things that I feel like can be kind of... Mic volume is low? I don't know. Let me check my settings real quick. Oh, it is a little bit lower. I hope that's better. Also, I've been moving my microphone around a bunch. Okay. Yeah, that's better. Great. All right. Yeah. So today that's what we're doing. But what are we doing tomorrow? What are we doing Sunday? What are we doing Monday? Well, um, this is the least exciting one, so I'm just gonna get it out of the way. I mentioned that I got a new keyboard. I mentioned it sounds really good. I'm hoping I do some keyboard ASMR in the process. But if you remember my old keyboard, which is actually right there on the bed, that's it's a dog. That's a keyboard. That's a keyboard, and that's a mouse. I probably could have pointed a little better, but I think you get the point. My old keyboard used to have this really cool feature, really amazing feature, especially for a gaming keyboard, which is what it was. I would reach over to touch the mouse, I would accidentally touch the top right key, and I would press it, and it would open the calculator, which was really fucking annoying. The new keyboard, unfortunately, does not have this feature. Instead, the calculator button was replaced with an X, and the top row is actually like circle, triangle, square, X. So I'm either playing PlayStation, Squid Game, or something else that I haven't figured out yet because these buttons don't actually do anything as far as I can tell. I've had it since yesterday, and I've been trying to figure out what they do. All I know is circle opens accessibility settings. That's the only one that does anything. Another thing which actually is really cool, but it's kind of weird, the print screen button, which has a little like crop like screenshot icon, opens the terminal. I use the terminal a lot, so that's useful, but why? Why? And it got me thinking about the fact that a lot of keyboards tend to have this kind of like custom functionality depending on the keyboard. And sometimes like the system can allow you to configure them, which I want my system to allow you to configure them. But either way, the system should understand what the keyboard is trying to send when you press a key. And for example, of all the keyboards that I have, which is like those two back there, I'm not counting this one because it's too new. I haven't tried it yet. Those two back there and another couple that I have, only one of those, which is like a basic office keyboard, actually works on my operating system on the Raspberry Pi. They all work on the virtual machine because it's not actually passing the keyboard through. It's just passing a QEMU keyboard. It's always the same no matter what your actual physical keyboard looks like. So that keyboard on virtual machine works well, but on the Raspberry Pi doesn't work amazing. And I'm finally working on getting it to work on the Raspberry Pi again. So it's kind of an important thing to do. I want to parse the HID report, which stands for Human Interface Device. And whenever you talk to a keyboard or a mouse, it sends you this information. You actually request this information, and you're supposed to parse it and interpret it so that it tells you essentially what format it will be talking to you in. But much like the HR lady did with your resume, I just request it and then immediately throw it away. So I should probably parse this and do something with it. The thing is, I know Wireshark can read this information on Linux. I was gonna install it, I haven't yet. So there's that. But it cannot do it on Mac. I have it on Mac, but it actually cannot do it. But on Linux, I'm pretty sure Wireshark can actually see this information. Because Linux just exposes it as a file, I believe, if I'm not mistaken. So I was thinking to just create a simple command line utility that can parse this information and then later on move it to my operating system. Because there's no point to having this functionality. I mean, it's useful, yeah, but it's not super useful on the virtual machine because, like I said, the only keyboard that we ever interact with on the virtual machine is the QEMU keyboard, which is a very basic keyboard in the way that it works. But either way, we should also parse the HID report for that one. Maybe it changes, I don't know. But it's gonna be a little bit before I get um, the USB controller working on the Raspberry Pi 4 and before it becomes kind of decent on the Raspberry Pi 5. I have to do some PCIe configuration and there's no documentation for it. So I have 3 sources to look at this documentation. I can look at the Linux source code. I hate that. I hate that so much. There's a bare metal library for Raspberry Pi called Circle that managed to make their code somehow more unreadable than Linux, even though their code is actually much simpler than Linux's. Because their code is C++ and it just abuses classes. Everything is a class. Everything. It's incredible. And I found out yesterday, BSD has support for the Raspberry Pi. So it also has this driver. So maybe I can look at their code. I opened it, but I haven't looked too much at it. But yeah, and this is actually my first time writing driver code for real hardware directly. So far, everything that I've done has been either for virtual machine first and then for real hardware, or some adaptations to get it to work on real hardware, but like 90% of the work was done for the virtual machine. So now every time I make a change, I have to recompile the whole thing, put it on an SD card, boot the Raspberry Pi, see if it works. I get no error if it doesn't work. So yeah, I also had to do a lot of maintenance to fix the system after I restructured all of it essentially in the past few months. That's done now. I'm back to having to work on this. But yeah, the HID report keyboard driver thing, not super exciting, not super looking forward to this one, but hey, maybe there's some keyboard nerds that really wanna see this. Let me know. We got a 3D renderer next. I realized I didn't have Blender on this computer, funnily enough, but I rectified that mistake. And yesterday, just for the sake of it, I ended up modeling a windmill. Look at this little windmill. It even has some basic colors, but haven't really bothered too much with the shading. But you know, you make a 3D model, you have to make a 3D renderer for the model if you have an operating system. Them's the rules. Not sure who came up with these rules. Maybe Terry Davis, I don't know. But if not him, then I'm coming up with those rules. So anyway, we should probably get started on making a 3D renderer. Also, not gonna lie, don't super love 2D game development. So if I can move to 3D, that's probably for the best. It's a lot of work. That's probably for the best. But we're probably not gonna start with rendering a windmill on it, especially with like little animations. This doesn't have animations unless I like manually move it. There's your animation. Ignore the fact that this doesn't move. Yeah, I just want to take it as an opportunity to make a 3D renderer. Hi, MX. So that was a windmill. I think, is it that bad that you cannot tell what it is? I thought it was decent. Yeah, so I'm planning to make a 3D renderer sometime this week, to start a 3D renderer sometime this week. And this is not like a 2-hour little project, a 20-minute adventure type of thing. But on Monday, I kind of planned how to make asynchronous services in my system. I've mentioned that I want my operating system to be distributed. And so I kind of wanted to make it so that through the file system or through a library, you can request resources or interact with the system in an asynchronous manner for certain things that you don't expect an immediate response for. Right, so if I'm going to open a file that's on the hard drive, I can expect the response to be pretty quick. But if I'm going to interact with a machine that is on a service that is on another machine on the distributed operating system, then I wanted to do this in an asynchronous manner, because even though it's supposed to run on the local network, it's not like over the internet. Please don't use this over the internet. Um, then it can still take a little bit longer, and we don't want to freeze your system while we wait for the response. So some sort of asynchronous system should exist. On Monday, I prototyped something very rudimentary, very ugly. Kind of hated it, and I'm not gonna lie, I managed something. I have to admit, I have to give it to myself. It was very impressive. I managed to get a race condition on code that I fully controlled on a single threaded, non networked system. And I got a race condition on it. And even after I fixed it, it was still there. So hey, props to me. That's genuinely a difficult and impressive thing to do. So hopefully the second version, the proper version of it, is going to be a little bit better. But I was thinking the 3D renderer is probably the best way to get started with an asynchronous service. It will be a software 3D renderer, so it'll be just a little service, a little process that runs on the CPU. The first version is going to run on the first core of the CPU. Maybe the second version, I can actually dedicate a whole core to it. I would like to make it so that the system can allocate, like the multi-threading can be a little bit, how do I put it? Smart or customizable. Like, hey, I don't have a GPU, or I don't have hardware acceleration for the GPU. Dedicate a core of my CPU to rendering. Obviously, the whole point of a GPU is parallel rendering, and this doesn't really do that. But hey, better than to share your CPU with the GPU software rendering and also all the other processes. So these async services can help talk to another core on the system, or this one doesn't really apply for the 3D renderer, because why would you use an external GPU? But you can also talk through the network, through the local network, on another node of this distributed system. This is what I was talking about Monday. So I feel like 3D renderer is both an interesting project that I want to do, and also an excuse to start properly building asynchronous services into my system, which eventually will lead to multi-threading, which eventually will also lead to distributed system, which eventually will also lead to world domination somehow. Yeah, so again, first version is not gonna use, well, it is gonna be like a synchronous service and whatnot, but it's a big project. So maybe I'll start it this weekend. It's also some very, very exciting stuff. Task management. Yeah, but essentially, I was asking on Discord what people use to track their tasks, their to-dos, and whatnot. Because right now, I have a notes file on my laptop and this thing. This thing here is kind of like the things that I'm planning to use, to do in 2026, which actually I want to go over because I've done quite a lot, and it has a lot of this into there. Obsidian. I mean, I've heard of it. But also, like, I like that I was able to draw like graphs here. So I was thinking, like, can I build something? I don't know. Eventually, someone recommended that I can just probably build my own solution. I would like it to be able to, for example, like get to get the to-dos from my project and like put them in the list of things to do. Kind of help me keep track of my projects and maybe, make what I'm doing right now, which is explaining what I'm going to be working on in the future, a little bit more visual. But yeah, I'm not really interested in using an existing tool because I was thinking, first off, could be a useful way to learn about databases because I have never built a database before. Or, most likely integrate the absolute goat, um, SQLite or SQLite, however you're supposed to pronounce that. I don't know. But anyway, even planes have it. So I should probably use it at some point or another. But still, interesting to delve into how databases are made and whatnot. Because again, even though I studied them, I didn't pay attention in class. And also, I never implemented one. So cool little project to do that. But the main thing that I want to do is kind of a local server architecture. So again, going back to the distributed file system, distributed operating system type of thing. Could I like build a server architecture out of these asynchronous services that I'm mentioning? The answer is yes. That's kind of what I modeled it after. I modeled it after an API, pretty much. So yes. But it would be nice to implement one. And the GPU thing, like I said, even though it needs to be asynchronous, it should probably be local, unless you're doing like a render farm from Blender, which I don't plan on supporting that. So I'm not planning on making my 3D renderer like I'm not planning on making the next Blender essentially. So not necessarily planning on running like a render farm or like an LLM off of my local network. So I don't plan on doing remote GPU, but it still needs to be asynchronous. And you shouldn't care about where it's actually running, whether it's a real CPU, a real GPU, a whole core dedicated to rendering, or just one process. You shouldn't care about that. You should just send it information and get back a rendered image. Or even just like get a rendered image. Pretty much. But the task management stuff could help me build a little bit of a local server type of, system. Essentially, I want it to be local. Well, I want it to be local on your machine, but also like since it is a distributed system, hopefully like, interact with multiple machines. Like, hi, Steve. Actually, the databases, I was thinking like probably not for the first version of this. First version of this, I probably just want to do like some very basic, um, like text document even, like even something like this. This is a list of projects essentially. So if this is a list of projects, you just format it a little bit better, and you have data that you can use to run the front end of the task management program, and then the back end built with the local server, and maybe like collecting that information, even if it is in a text or in a database, from different machines on the local network. So the 3D render and the task management, besides being programs that I actually want to build because I feel like they're useful, or I'm interested in building, both actually, can also help me flesh out a little bit of this distributed architecture type of system. I don't want it to work like you're communicating with a server, essentially. I don't want it like that. Even if it isn't, I want it to be serverless. Even if it is just a distributed server, technically. But yeah. And finally, there's HTML and SVG, HTML and SVG rendering. Honestly, I want to do this. I don't necessarily have a use case for it. How do I put this? I don't want JavaScript, like in the slightest. Like, fuck that language. Fuck it. Seriously. So, I am not interested. I was not joking when I said if I find JavaScript, I will panic your system. I was not joking about that. So I have no interest in browsing the web from redacted OS, also because the networking stack and the entire kernel are super insecure. So if you do that, that's probably the equivalent of like, um, I don't know. Putting a target on your back. I don't know. I don't know where I was going with that. I was kind of broke down. Um, so you probably don't want to do that. And in that case, any code that runs on your machine, you can just install. But if I find a reason to do HTML or SVG rendering, then I will do that too. You see, with all the other things, I have practical reasons why I want to build them. Even the compiler analysis that we're going to do today. For this one, I don't necessarily have it. Because like, yeah, for example, the task management software will need an interface. But I could build it with HTML, but then I have to build the entire HTML renderer. So I might as well just build the interface natively. So it's kind of just like, if I find a use case for this one, I'll include it. But otherwise, I really only added it to this list because I ran a poll on what I should work on, which is when I started working on the compiler, and it won. Do I still have it open, by the way? Ah, it's probably here. Also want to see when I started working on the compiler. 3 weeks ago. So yeah, it actually got 2 votes. 3D rendering got 3 and compiler got 6. But yeah, I only added it because it was there. Language that I'm making, I guess it's called Cred. I say that every time, I guess, so I'm not sure about that name. But yeah, right now it looks a lot like C. Eventually, I'll probably start changing it up a little bit. It's very easy for me to change the syntax, so that. In the test management, a priority queue? Maybe. We'll see. Really, the first thing I want to do is not a task manager, but just something to display my tasks. Because right now, I literally just have like either this thing, or an ugly ass text file that's growing way too much on my laptop. So even if it is still just a text file, but with a cute renderer on top of it, I'm good with that. If you don't know JS, you don't get a job. They need backend, but you need to know JS. Yeah, is it like backend and like Node and stuff like that? Keep in mind, the task management software most likely will be cross-platform. Because every like userland application that I build can be cross-platform now, so yeah. The 3D renderer doesn't really make sense to make it cross-platform, because most likely I will make it to conform to OpenGL API, so I can just use real OpenGL on Linux and my software renderer on my system until I build a hardware accelerated renderer. Way off in the future. Java and C# and you still need JS? Why? D is C# without extra .NET baggage. Seriously? Interesting. Okay. So I'm gonna obviously continue streaming compiler stuff, and pretty much all of these tie back to the operating system. These two kind of immediately. Well, this one immediately. This one pretty early on. This one probably also pretty early on. So I will continue streaming compiler stuff and I will continue streaming operating system stuff, but I will do it through one of these um, projects. And you know the cool thing about making an operating system and a compiler? Turns out, um, you never really stop working on them. Because if you make a language, you use your language for your projects. Bam. There you go. Project's not abandoned. I'm using it, actively maintaining it. So it encourages me to continue working on my language. And then if I'm targeting my operating system for the programs that I'm doing, it encourages me to continue working on the operating system. So yeah, if you're here for the compiler stuff and the operating system stuff specifically, that will continue. Even if the focus is on something else, it's kind of gonna be all related. It all ties back. It's all compilers and operating systems deep down. So those projects will very much continue. Another thing I'm actually adding to this list. I'm low-key starting to create a format for my task manager with this document. Text editor. Because of course I have a compiler. Should be able to edit text, right? And I guess this one's kind of set. Well, no, I'm gonna keep it. It's part of the compiler work. An LSP. I have no idea how LSPs work. Like zero clue. Other than they use JSON and they're technically a server, but running on your local machine. I think. Anyway, I hope they're running on your local machine. Because if not, Jesus fucking Christ. Also pretty sure they were created by Microsoft. So I can just imagine what it was going to be like to make one. But I probably want one because, yeah, right now, Clang kind of just like struggles a lot with my language. It's like, what the fuck is that? What? And I get it. But I wanted to be able to syntax highlight properly. But that's part of the compiler work. So, yeah. All right. There's an ad coming up. So we're gonna run that. And then we're going to begin with the compiler work. So not used to what keys I'm supposed to press here. These two, okay. New keyboard, bear with me, please. But hey, isn't it pretty? And doesn't it sound good? Sounds so good. Again, not sure if you can appreciate the sound, but it sounds good to me. And that's mostly what matters. All right, I'll be back in 3 minutes. back a little early as a little bonus. I just saw that RTX 1590 5000 recommended price is insane. Can you shut the fuck up? Hello? Am I reading this wrong? Am I... It's gotta be wrong, right? It's just like Amazon US too. Probably refurbished. Yeah, right? I was gonna look for SSD prices, and then I saw that message. It doesn't look refurbished. Oh, 200 euro shipping and import. Then again, this is again Amazon America. All right, RTX 5090. I'm not planning on buying one. I have an 4080, I think. All right, this, yeah. What the fuck was that? What the fuck was that one? Are prices in America just... No, the prices in America are like crazier than here. This makes more sense though. What are you complaining about? Just FYI, we're not very happy with each other. Let me just say, one of us, not naming names, but one of us ate something off the ground and the other one got mad at him. Who's who? Not saying. But yeah, we're not on speaking terms. What does core mean? Yeah, less tariffs. Oh, GPU core. Yeah, but what do you mean no core? I guess now I compare it to the other one. So that was kind of a crazy thing. They removed the core and sell? Marks the brand as generic, which is kind of weird. But they have reviews. It has 0 reviews. Okay, it's starting to look real sus. Same for this one. Prices here are starting to go up, but they're still not... But this is a 5080. Sometimes you get a GPU without a core. Christ. Oh, fuck AI. What I wanted to look at is SSDs. Is this Amazon Spain? Yes. Yeah, they're not cheap. They're not super expensive. They're not GPUs, I guess. Amazon is medium to high risk for GPU RAM at the moment. I'm not really looking to buy one, I'm just looking at prices. Alright, these don't feel super expensive. It's been a while since... why would you buy a GPU off Temu? You cannot possibly... If you get scammed on there, and you call them to tell you tell them you got scammed, and they just like laugh at you and hang up, you deserve that. I'm sorry. And if you tell me that you got scammed buying a GPU off Temu, I'm also gonna laugh at you. Come on. Everything you buy on that fucking website is a scam. What made you buy a fucking GPU off it? Maybe you get one of those little like miniatures, like when people buy couches and then it's like a couch that's like this big. It was 449. Okay, now I want to see Temu. I don't think I've ever even been on this website, so. Holy hell, I can smell the slop from here. Oh my god. Maybe a little bit elitist, but god. 10k changes in a project? Damn. Alright. Please let there be some. Please let there be. I need to log in to search? I need to log in to search the slop website. What the fuck? Do I need to log in to look at these €6 shoes? Yeah. But I'm not willing to log in. What makes you think I want to download the APK? I mean, I'll download an APK because I have an iPhone, so I'll definitely download that. I'm not gonna log in. Don't worry about it. I would never do that to myself. And lucky my Bitwarden is locked, because otherwise you would have seen that I already have 10 accounts. Can decompile the APK. You can technically decompile the IPA too. It's a little bit harder to get it, but it's not that difficult. Wait, no, because it's encrypted. Forgot about that part. If you have a jailbroken phone, you can do it. Yeah. Oh well. Let's begin with compiler stuff. Alright, so I mentioned the problem that we are facing. I was able to create an interface because sometimes OOP is OP. And so we're doing some OOP today. This syntax is technically valid for my language, but like I said, it needs to create an instance of CodeGen that has the function pointers for BLK code, and it currently cannot do that because it needs to look up information into the symbol table, which it cannot. 8,000 euros? Yeah. Which it cannot currently look at because the symbol table is messy as hell, to be nice about it. So we're gonna clean it up a little bit and make it actually usable. That's the plan. ROG Matrix Platinum GeForce 5090 32. 8,000 euros. Please stop using AI, people. Please stop using AI entirely. It's not worth it. It is not worth it. Oh, I haven't saved. That's why there's changes in here. Yeah, when the bubble pops. I hope it takes all the big tech companies with it. We do deserve a reset. Apple's maybe the only one that isn't just like scamming the rest of us. They're kind of pushing for like local AI. It's shittier, but hey, that just speaks to how little of your information they actually steal. So maybe Apple can stick around. But yeah, all the other ones can go. I don't care if I have to be a. What's an alternative to YouTube? Microslop? I love Microslop 100%. Best word ever invented. In the second half of January 2026. It's been less than a month, by the way. Just FYI. We're less than a month into this year. Just a little reminder for everybody. Okay. So let me look at first off. I'm going to clean up my code a little bit. I'm just going to delete anything that is irrelevant. And we are going to compile just this. So just an interface and a structure that conforms to it, right? Which creates a vtable kind of for the interface and a structure for the properties of the actual structure, functions for it, and then an initializer for it, and generic functions that you can call. Enshitification was not enough. They had to go with enslopification. It is, though. Stop calling it slop. Stop calling it slop. It's not slop. It's a cognitive amplifier. And he's not wrong about that. It's just that, like, I don't think anyone at Microsoft has a brain, so what is it amplifying exactly? Okay, yeah, so it generates, the header file is good, but then when it comes to generating this, it is not good. First off, it is not generating the actual functions for the structure, and I'm not sure if I'm intentionally limiting that or if that's a bug. It is generating the functions for the interface, but not for the structure, so I need to look into that. Also, hold on, just to test, I'm going to create another type without conforming to a interface, and I'm gonna create a function for it, and I'm just gonna print hello in this function. I'm going to compile this, and yeah, I created the function, but it didn't output it. Okay, so that's a bug. That's probably a bug. All right. So that's probably the first thing I want to fix. And that's in CodeGen rules. I have to. CodeGen is going to be the new folder that I use once I get rid of the code that's in here. Once I translate it, essentially. But for the time being, I have to remember that my actual code is in CodeGen rules. And I'm looking for struct code, which generates the code for the structures. So, by the way, I'm finally using, well, I was already using it, but I'm using it more, that ternary operator that I created the other day. Because I mentioned, by default, the compiler will generate a .h and .c file, unless you specify the extension that you want, in which case it will generate only that file. And when you generate a header file, there's some stuff that you don't include, like the function implementations. You only declare the function without implementing it. In the C file, you only implement, but for example, you don't do the type defs. But when you specify the file, I just assume that you want all of it, and I give you all of it. So I'm using a ternary operator is header, and depending on that value, it outputs some or all of it. All right. So this here is what's creating the type, which again makes sense. This one's working fine. This is a debug log that I probably should have removed. Don't think that was supposed to stay there. This is creating the initialize function if it has a parent. If it doesn't have a parent, it doesn't actually do anything with the functions, funnily enough. But it does create the functions in the header file. It just doesn't implement them, but it does create them. They're here. And wait. No, wait. It doesn't create this. Wait, no, did it? Yeah, here it is. It's just not here. Okay, so in the header file, it's working, kind of. Yeah, the header file is correct. What's incorrect is the C file that's being generated. So that's when is header equals false or not true. Just keep in mind those are different things now. Ternary operator. So not true. Here it is. It only emits this. I see. Whereas instead it should emit the actual like contents of it. But it isn't. Shouldn't you actually still be emitting? Wait. What I'm not seeing anywhere here is what's generating the functions. And I'm pretty sure it's being done by this emit code with the contents of the structure. They just get sorted. Properties get put within here. And then functions get put in the epilogue, which gets put at the end of this by this thing here. So it looks like actually that log was probably me debugging this. Has an epilogue of 90, has an epilogue of 55, body of 1, epilogue of 0, body of 1, epilogue of 0. Alright, hold on. Let me just have one structure, no parenting. Has a body of 46 and an epilogue of 45. But then there's another one that's printing this. Why is it printing twice? There's only one structure. Tell me the name of who you're outputting. Code name, which is a slice? No, token. So token to slice code name. Block another type has body of 46, epilogue of 55, has body of 1, epilogue of 0. Why does it seem like it's being generated twice? It's only created if there's a struct rule. And based on my rules, here and here, there's only one way of declaring a struct. It's only created by this. So that's kind of suspicious that it's printing twice. How can I find out who is doing this? Because it does look like has an epilogue, which means... Oh, wait, once for the header, once for the... Okay, that's why it's twice. Yeah, that makes sense. All right, so this is the short one. This is the epilogue of 55, which is this. Yep. And this is the body. Right, so in here it contains all the properties, it just doesn't have any. And in the epilogue, it puts the function declaration. But then it puts nothing here and then nothing in the epilogue. Well, it puts one probably new line here and then an epilogue of 0. So, okay, now I understand my code. What a magnificent thing. That probably goes in the function declaration, which is by far the longest one of these functions. because most of the code is going to be inside functions. So the function creator is going to be quite messy. Does it have any kind of early return? I don't think it does. So, okay, well, tell me. I pressed the wrong key. This keyboard inverts the command and option keys. It also has a Mac layout, but that's fine. I'm actually used to that one. It's just like it inverts the Windows and Alt key, I guess. So I keep pressing the wrong key. All right, function sig name token to slice. Only once. Oh, I just realized. Hmm? Hold on, I think I just realized what's happening. It's really dumb. It's really, really dumb if it's what I think it is. It is not what I think it is. But it probably is what I think it is. Which is essentially that some block in between the structure and the function have an early return if you're not in a header file. Like this one. Probably exactly like that one. That's the only one though. Yeah, but how do I know which one? I need to trace the path between the structure and the function declaration. All right. You can declare a block which contains a statement which contains a struct. The struct contains the word struct, a name, a brace, a declaration block, and then it can have an identifier, colon identifier parent. That's not the one that we have. We have this one. But either way, it calls the dec block, which has a declaration. Which can be declaration with a semicolon or a function declaration with a semicolon. And function declaration is tagged as func. So I'm really surprised that it right. Let me try to trace the path of what's happening. The struct code should be generating its contents, which in the header file it does correctly. So there's probably some early return somewhere that should have an exception. It then probably goes into a block, which generates this block. The block then goes into the function. Which does this. So for the header file, we should see all three prints. For the other one, we should see where it stops. All right. It starts generating output, block contents. Okay, that's the first one. Generating contents. Scope. Function. There it goes. Then generates it. Then it goes to the other file, block contents. And then the structure never outputs. Oh, it's literally right here, huh? It's literally right there. Literally right there. There's our function. Okay. Ternary logic, everybody. We love it. Look how cool, I just created the ternary operator. It's useful for situations like this one when you have 3 cases. Breaks. Uh, Amazing job. Amazing, 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 amazing. Absolutely amazing. Okay, get rid of that. And what was here? Oh, just a print. Yeah, get rid of that. All right. And bring back these interfaces, and we can get rid of my helper function over here. So we build, and here we have the declaration of the interface for the vtable, kind of, the general function calls, the declaration of the properties of the type of the structure, the specific functions for the structure, its initializer, and its implementation, and the properties shouldn't be there. Those properties should not be there. All right, those properties are declarations. So the declaration code, where are you at? Um, if we're explicitly in a C file and we are either doing a structure or an interface, we don't want to redeclare its properties, so we do an early return only there. Now the output has them, and this has a bunch of empty space. Yeah, I'm gonna have to fix the empty space problem. But it did work. It creates the function, the test function, and yeah, this parent code should not be there. No, well, yeah, it should. Kind of. It's technically correct. It's just like using an extra step here. Because you could just make test type instance instead of parent here. But honestly, I'm going to waste too much time on fixing the code generation. This is why I haven't been streaming the compiler work. Because it's been a lot of this. A lot of, oh, technically correct, but if I put this here instead of here, and I put this here instead of here, it's easier, blah, blah, blah. Just a few edge cases, lots of it's if statements and whatnot, so. We're gonna ignore it for now, and we're just gonna push these fixes real quick. Right, so the early return for the declaration, and still emitting code here and getting rid of that. That's the only change that I want to push. No changes in output. Don't want you to commit that. Structure function emit in C fix. Okay, and okay, I wasn't sure. I didn't create. Okay, yeah, I need to do this. A helper function inside of test type because I explicitly wanted to not create the vtable for it. Output.c. It should create the function itself. And again, it should have access to the instance here, but again, technically correct, just a little bit of an extra step. Functions are being declared, but then it won't need to be here. All right. So in order to know how to conform to an interface, then we need to know what symbols we're declaring for that interface. Right? So technically, I think we have all the symbols. They're just not sorted in any manner, so we probably need to take care of that. Let me see. Is it backwards? Yeah, it starts kind of backwards and forwards. It's a little bit weird. It's like backwards on a line, then next line, then backwards. So it starts with elem type token, which is a parameter. Rule type int, which is a parameter. Instance doesn't actually exist in it. Because that part is generated for the C code specifically. That's not really part of the symbols that are actually declared in the code. If I look at this, that's not actually there. It's lm token, an int rule, then a function called func of type void, which is a func, and a function called test, no type, should result in void, but it isn't right now, of type func. Then, kind of same thing, lm token param, rule int param, func non func, a int dec, inside of the function, empty non func. That's not right. What is the symbol? Who created you? Oh, is it just like because they're chained together? I think it's because they're chained together. So this one shouldn't be emitted. Neither should this one, neither should this one. But because this comes after this, and this comes after this, it's kind of chaining them together. So it's creating these empty symbols, which we don't want. Then it's creating a function called test, no parameters or return type known, and a function called helper, no parameters or return type known. Good. And then the properties of it. Funnily enough, there's currently no rule to generate a symbol for a type, so we need to have that. And also, another big limitation that we have right now when it comes to checking these is the fact that all of them kind of exist within the same symbol table, I believe. I don't believe I'm making a separation between them. Find symbol, analyze semantics. Yeah, no, none of that. Did I make a change in here today? I feel like, okay, I kind of hate when I have two functions that do the same code, but have different implementations of what they do with that code. So then you have to keep track of two things, essentially. Like, for example, this use of the ternary operator here. Okay, the res is the same. If res is not true, then if it fails, you print an error and you return. Otherwise, you're just done. Yeah, that part is good. Okay, what emits a symbol is based off of this giant if statement. Well, it's not big, but it should be, because honestly, it's kind of dumb. It's kind of a very dumb table or way of doing it. Because every time I add a new type of symbol, I have to expand this if statement which I already have to do in the rule generator. I don't want to have to do that here too. I actually don't want to do it anywhere. I should probably fix that, but can I replace it with just checking the symbols? No, not really. It checks if a symbol is a label, checks if... I really need to remove labels from the language. But probably keep them in the compiler. I think I'm gonna have to keep it like this for now. I don't want to refactor my code too much. Did I just do the same exact... Yeah, there we go. Okay. If it's a function, a parameter, a label, a declaration, or a function again, apparently, it gets added to the symbol table. However, that's not enough. It needs to be also a struct or a interface. So now we have a struct test type and an interface called hello. The rest stays the same. Now another thing is if a symbol doesn't have a name, you absolutely should not output it. No, I can't break. And that gets rid of those ugly empty statements, which came from, like I said, the symbol chaining. So a function declaration is made up of... No, actually, the way that it's used. A declaration has a declaration of a variable or a declaration of a function, followed by another declaration block, which is, again, same thing. But it leads to empty... Oh, wait, no. Oh, it's this one. This should actually be name, probably. I think that's the problem with it. I do wonder if I can remove this. Maybe I'll just break everything, I don't know. If the function declaration, the func sig... Oh no, it's a nested rule. Because a function signature can have no return type or no parameters. So name is there, but it's here. Okay, it's because every function is nested like that, essentially. So yeah, we want to get rid of that. What I wrote was actually correct. To just very quickly filter out those symbols. Okay, cool. I'm gonna take a little detour to see if I can simplify this. By kicking the can up the road, I guess? In the rule generator, pretty much. There's already an if statement that looks like this in the rule generator. It's gotta be... Here it is. So these are declarations, and it knows that they're declarations. The problem is it doesn't keep track of that. But we can keep track of that. Oh, it keeps track of that internally, but then it doesn't do anything with that information. So entry declaration is dec. And then when you output this rule entry, No, not there. Here. When you output this rule entry, you have to output that name action, I'm pretty sure, is pretty misleading. It is. That's gonna be a pain. Can I do rename symbol? Will it work? It worked. Okay. It was able to rename a symbol. I wasn't sure. Clang has been kind of iffy with this project. It has a bunch of C files that I should technically ignore and whatnot. But anyway, sem action. Action. What it should actually have is that. And then in the rule parser here, sem action, what's the name of it? Declare or check or none. V. So this is based off of whether E declaration that, well, not V actually, it's a literal. Then declare, otherwise check. No, none. You don't do anything if it's not a declaration. And then I should be able to replace this giant if statement with just if sim dot, wait. With this thing. Action equal to sem action declare. Rules.c is not really meant to be readable. It is very unreadable, you got a point. But it's not meant to be readable. This one is meant to be readable, and honestly, it's already kind of painful to read. But rules.c, I'm not super interested in making it readable, to be honest. I changed the way that it works to use the new like code generator that I created and all that stuff. And I probably will change it more. I mean, I'm thinking that if I really want this compiler to be kind of like able to iterate over syntax and whatnot, like to prototype a language, then I'm probably better off making it load the array at runtime. Not really generating the array in code, but generating it in another format that then gets parsed into the compiler. So that's probably what I'm gonna end up doing. And then it's gonna become completely unreadable. It might even make it just a binary format. I don't know. I don't think it's super readable, even how you say. It used to be like that, to be fair. It's just that when I changed it to use this new rule, code formatter, it doesn't automatically insert a new line at the end of it. But let's give it a try. You know what? Put a new line here, and that should already do that. And also a new line here. That's probably too many new lines. Oh yeah, hold on. I just got rid of that one. So now every rule is on a new line. That already makes it a little bit better. But I do like that you can read a rule like this. It's a statement followed by a scope. It's a statement. Um, it's the fur. It can get a little bit long, but there's none that are that long apparently. On syntax highlighting for rules.config. Oh, an empty line after every line in rules.config. I just realized you said that in rules.config, not in rules.c. And hey, blurry square. Plugin? I don't know. There's LSPs, which are compatible with most code editors. And again, I did say I probably will need one for my language. But they were created by Microsoft, so I'm dreading a little bit knowing how they work, to be completely honest with you. Let's put a new line here as well. Alright, I'll mix it a little bit. It's way longer. And actually all the brackets make it a little bit harder to read, I would say. But hopefully they put a little bit of space in between. You can kind of read what's going on. Alright. Like I said, probably will become a binary format in the future, so. Or maybe not even that. Maybe it just like parses this every time, though that's not super efficient, but hey, whatever. Plugins for Z. Wait, were you looking into that? Oh, you have been making one. Interesting. But no, I think for syntax highlighting, you kind of just need an LSP. And I don't know how they work. Probably something I want to do for the compiler at some point, but I didn't put it in the project ideas because it is part of the compiler. I did put text editor. It's kind of part of both of those, to be fair. Although it would work on Z as well, because yeah. Not sure that I'm trying to replace Z anytime soon. I just want something that works on redacted. Now that I do plan on having it on real hardware, I do plan on using it more. But I don't know that I'm ready to replace Linux, you know? So Z is fine for now. Okay. So I believe we have all the symbols that we need. I just have Ubuntu. I don't use Windows. SCM. You know, I've never built any like plugins or mods or anything like that. So I don't know what it's like to modify a program. Never done. Maybe I should do that someday. Just a little bit like off topic for fun type of thing. Another recreational programming session, you know? Okay. We should have all the symbols that we need, but they're kind of unstructured. So that's the next thing. The function name is here called func. The other one called test. And then the ones for, oh wait, for the interface hello. If you read it backwards, it has all the information that you need. The interface hello has a function called test, no parameters, no return type. It also has a function called func, void return type, rule parameter of type int, element parameter of type token. If you read it backwards, and the same thing goes for this struct right here. But we don't really know where it starts and where it ends. And like I said, everything is being put in the same table, whereas I don't believe it should be like that. So let's, you know, I don't know why I have this open in the red lib. Oh, that's another big change that I made, by the way. I moved my shared library from the operating system to its own project, redlib. I also moved the cross-platform library, which was just an implementation of this library, into this one. And most of my projects just call it by expecting it to be in your home directory. Whereas the operating system, which is the main one that people tend to download, uses a submodule for it. That's my first time using submodules too, so that was interesting. Yeah, the compiler will probably use it as a submodule too, because I want it to be as standalone as possible, and relying on a specific structure is not standalone. But yeah, the compiler and the build system will need to be that way too, but I'm not in a hurry to do that since nobody's using them right now. I'm fine with just hard coding the file structure. But anyway, yeah, I have my project ideas file open in the same like folder as this, and that doesn't really make a lot of sense. So I wanted to open a new file. I wanted to open a new file. I wanted to, oh my, what the hell? Okay, so all my symbols are in the same place. I was kind of looking into how it should be. First off, do we have a code action? No, none actually. To see like, I just wanted to invert this because it is backwards, but it's only partially backwards because the interface, first comes the interface, then comes the function, then comes rule, then comes elem, then comes the test function, then comes the, I keep pressing the wrong key. Again, bear with me. I should be better at typing with this keyboard, but then like modifier keys, I need to get used to them still. All right, test type, followed by func, followed by root, followed by element. Where does A go exactly? I'm not sure. Empty function test, empty function helper, and then these two types. Cred is not going to have header files, no. Right now I'm just making everything public. Full disclosure. Probably won't be that way always, but Terry Davis had a point. It's func test helper, then the properties. And in A is part of func. Ah, that's where A goes. So yeah, it's fine there. Test helper and then the properties. Okay. So I ordered the table manually, but it was kind of weird. It had all the interface code first, then the structure code, which is right, but the interface code was backwards, and then the other thing was backwards. So you kind of just read it like this, which was kind of weird. Hey, puppy. But the main thing that I need to do is separate them into scopes. So we have an interface, because again, what I want to do is test type conforms to to hello, to the hello interface, right? So it needs to fetch all the symbols of that interface in order to understand what symbols it should declare, right? So what symbols are those? The function func and the function test. Then the function func itself internally has two parameters, rule and elem, which are like that. And no, that's good. Func test, func helper, kind of like that. If you look at the structure like this, you can kind of understand how it should be handled, right? So first off, test is a child of hello. All right, hello declares a func. So does test. So far, so good. Inside of func, it has rule of type int and elem of type token. Rule of type int, elem of type token. So far, so good. Then test type also declares a declaration of an integer called a, but that's its own problem. That's a local variable. We don't care about that. You can do whatever you want inside the implementation of the function, as long as the signature of the function is correct. So we don't care about this one. We don't check it against this, but we're good. Then we expect to find a function of return type none or void named test. And we do find a function of type none named test. Or we could find it of type void. The typing is another thing that I'm probably not going to have enough time to handle today, considering how little I've gotten done in the last 2 hours. And then it declares another function called helper. That's just internal for it. I don't care what it does with it. It's not part of the interface. I'm not checking against it. And then it declares two properties, which again, not part of the interface, not checking against them. Cool. It's that simple. It's that simple. That's how it should be handled. However, that means that all of these need to be new symbols, kind of. New symbol tables, essentially. How do we know when we have to generate a new symbol table? Right, each indentation level is a new table, which is then linked to this symbol here. How do we handle this? That's a good question that you're asking. Totally not me talking to myself, right? And I will tell you how. I'll tell you how. Yep. Wait for it. I got the answer for you. All right. Let's do it in print first, because it's always easier to do things in print, right? I'm probably going to need to abandon my stack only. Oh, I've already done this with the codes generator, so I need to abandon my stack only approach of not allocating ever. It's no longer going to work here. But do I have enough information to do this? If I look at a block, that's no action. Statement should be no action. Defer, no action. All right, what about assignment? No action. What about declaration? Function declaration, declare. Func. Function signature, func, declare. Function arguments, don't declare anything. They should have a scope, I feel like. Well, luckily there's an ad break, so I don't have to think about it for the next 3 minutes. I'll be right back. Right. We're back. And it's officially time to ask myself the question, why is my bitrate varying so much? I'll just check my settings real quick. I'm not sure what it's set to. It's supposed to be um hmm. Alright, well, anyway. Let me know if there's any problems with the stream, but it looks okay. For the time being. On my end, anyway. Okay. So, like I said, there should be a new symbol table. When exactly? First off, when we have a new function declaration and not function parameters or new interface or new struct, technically also internal blocks should do that. Like a variable declared instead of an if statement is not available outside of it. But I'm okay with not having that this very second, because the solution that I have right now may not be the best. So right now I'm using the cred extension for it. In the build system, I'm using the redb extension, but it's the same file. It's just for the red build system. So couldn't call it bread. So yeah. Okay, and I did say the problem is that the symbol only gets printed backwards, but that's a print problem. That doesn't change the fact that the symbol actually kind of exists here. It just gets printed here. It shouldn't be too difficult to do the order correctly, for that matter. I can just do it like this. Right? Like this. And then this goes here. Please don't break. Please don't break. Make sure the sim exists. And then use it. I'm starting to get used to my keyboard. Just nice. And I'm still doing the printing inside here, which is not right. I can just get rid of it. Hold on. Get rid of it, but copy the code, not just delete it. Okay. Don't return. Symbol count. Oh, the if is missing. No, wait. Hmm. Okay, there's gonna be some cases in which it generates like empty names, and for the sake of simplicity, I'm just like backtracking. Or not. Or not. Oh. Oh, it can happen here as well. Okay. Boy, do I wish I was doing this in my language so I could have the fur. Boy, still. I'm still doing the same hack as before. Wait, no, okay. Yeah, it's good. I just still need to do the same hack as before, which is that it's the symbol, table, object at index I, name, length. You print, otherwise you skip. Right. Is that correct now? We have an, well, we can actually compare it against the other thing that I did. Interf with a func called func, a rule, elem, test type with a func, a rule, an elem, a test, and these are missing. Well, isn't that beautiful? Right, can we not just not do this backtracking real quick? Because it's probably the reason why. That's the reason why. Also, this backtracking is ugly, and I'm not doing that. Okay, now we have... Why do I try to copy from the terminal? It's been like half a year I've been on Linux. I still try to copy from the terminal. Secretly hold on to hope that Linux will become a reasonable system. Because I'm foolish like that. Okay, so the symbol table is now ordered correctly. Which again, it was just a matter of ordering things. It was just a matter of optics, really. But it was kind of important. But it isn't indented correctly. In the sense that some of these rules should be generating a new symbol, sorry, a new table entirely, actually. And I'm not sure how to do that. I'm not sure how to handle that. Again, I was gonna do it in print, Just like after you're done with that symbol, you just emit like a hey, I'm printing the next thing. But again, this stack-based symbol table is gonna go away. Once I figure out this rule. Again, let me see my rules, right? Yeah, this is, without syntax highlighting, this just looks like a wall of text. I really hate working with it in this manner, but you wouldn't happen to have a, what is it called anyway? This syntax? Well, I've already changed it. BNF. Can I search the marketplace for it? There's brainfuck. But that's it. Is it Bacchus? Nauer form. What an incredible name. I'm assuming it's two people, 'cause why else would you name it that? History. Nini was a Sanskrit grammarian. Okay. Goddamn. Working with shit from like the 6th and 4th century. Alright, here's Bacchus. Don't stare at me, man. That's creepy as fuck. And here's Naur. Not Australian. Danish. Alright, cool. Baksu. Nope. Naur. Well, I don't know what language Bison uses. Bison yak language parsing. I just want to look at code. Or whatever the fuck they use. Machine readable BNF. Interesting. Yeah, that's probably machine readable, alright. No, wait. Ah, no, this is not. That was also not machine readable. I don't know what the fuck I'm talking about. Well, I have no idea what this language looks like. Yak grammar, maybe I can look that up. If I learn how to spell anyway. The Yak grammar file. Yeah, that's not it. Yuck. Yeah, another compiler. Look ahead left to rightmost a derivation, a Lalor parser generator, generating a Lalor parser. What if compiler tries to make sense of syntactic code, written in notation similar to Bacchus Naur form. Okay, this is what it looks like. Alright, so it's nowhere near mine. It's not even gonna try to attempt it if I try to run this into it. I could just make it look more like it, but what's the fun in that? I probably should. We probably could do that. But the tagging is probably going to be the easiest, the most difficult part. But what am I losing by just installing the extension real quick? Yeah. It might look yucky. What happened? Wait, there it was. No, it wasn't. Bison. 0. Nothing. It didn't detect a single thing. God damn. Not one line and not a little bit. Didn't even mistake it for a second for valid bison. I mean, it looks like this. Would it be able to compile this? Or like to recognize this? Not really. Oh, still not really. Because it thinks that this is a string, but this is not. Oh, oh, well, oh, shit. Oh, never mind. It switched to C. That's why it worked. Well, you know what? I prefer looking at a pink wall of text than a white wall of text, at the very least. Um, yeah, what the hell? I'm keeping it a C. If only I could save it, because every time I open the file, I'm gonna have to. Well, no, not every time I open the file. I guess every time I open the editor, or every time I close it and open it. Yeah, every time I do that. And I have to choose that it's a C file. Can I force you to use it a C file like always? No. Well, whatever. I guess again I prefer this over the other thing. Over the wall of text. And I probably need to fix this, otherwise, yeah, the language is gonna stop working. Alright, again, now actually looking at it, when do I need to generate a new symbol in this case? First off, when I have an interface. Yeah, would this be more readable with... Yeah, I should probably do this. I should probably do this. This won't actually parse, that's the problem. Unless I make it have a double new line. Yeah, maybe I'll do that. Either way, I'm getting too sidetracked here. I'm not getting anything done. I was supposed to get all of this done today. All right, an interface is where we declare a new scope. But after the interface, we declare a new scope. Hey, buddy. Hey, buddy. In an interface, when there's a new function, so in a function declaration, and when there is a new... That's it. In this case, inside of the function as well, there should be an... Well, no, it's the same one as the parameters, pretty much. It's looking like a big refactor here. Which is kind of what I'm... Yeah, I'm probably gonna end up doing. This code is starting to become a little bit too unsustainable with the stack structure that it has. But just for the sake of it, if symbol table I sim type equal to sem rule oh no. Yeah, no, this semantic rule, okay. Interface. This is where we end up with a whole super ugly giant or statement. Because just to support these three rules, I need to do it for structures, I need to do it for interfaces, and I need to do it for functions. And because there isn't any real actual nesting going on, we don't know where it ends. Interface. This goes in the global table, right? Because the interface is available globally. It has a new table. It declares a function. The function declares a parameter, and a function. New table. Test type. Yeah. So the rule is correct. I just hate that I have to hard code it for everything. But okay, it's looking like a refactor. I'm not gonna waste more time working with a structure that I definitely need to refactor. We're going to just create a new function table. Wait, no. Wait, hold on. Actually, we're gonna type def a struct symbol table. Inside of it is gonna have certain amount of symbols. We're okay with just keeping it at 64 right now. That's more than okay. Does the order of the symbols matter? I'm thinking not. I'm gonna treat it like it doesn't matter. All right, and the find symbol function, not really using it for anything at this very second, so I'm just gonna not make it super complicated for myself. All right. So we start by creating a yeah, let's just call it table. It's too messy. Okay, we're going to start by creating a new symbol table. New table. And we're going to pass it off to our functions to analyze. Everything is going to be put in there. And then we are simply going to be able to iterate through it. Mm-hmm. Not gonna lie, not liking any of the code that I'm writing today. Not super happy with it in the slightest. Anyway, we're going to debug the table, the global table. And we're going to just iterate through the table's symbols. And we're going to make sure that the table's symbol I has a name with an actual length, and mark this as a hack. Because again, there are some rules that use the same symbol and they end up being counted as declarations when they really aren't. Like the function's signature is counted as a declaration. That's a little weird. But I don't want to review my rules right now. It's going to be too much. So instead, I'm just skipping the ones that are empty for the sake of simplicity, I guess. And remembering that they're a hack. And sadly, I removed the code that printed the this code right here. It's very useful. So oh, there's no need for this to be a pointer actually. There, so we can just print that. Oh wait, when I call this function, I need to pass the table as an argument. Okay, we end up with the same thing. Interface hello, function, rule element test, test type function rule element, a, test helper, prop1, prop2. Cool. The tables currently have no way of keeping track of their children. And let's let them keep track of that. And then just go through its children. Table children I. That simple. Now, okay, this again becomes kind of a hack in the sense that if the current semantic rule is, again, sem rule function, or it is a struct, or it is an interface, right now only these three, then the current table gets set to a new table, and that way all the symbols inside of it will be created inside of that. But the current table will be preserved by it. And of course, the table needs to keep track of a new child. Table child count plus plus equal current table. And we start with the global, hold on. Let's put a little bit of a separation here. Okay, we start with our global table, which just declares two interfaces, or two types. Interface hello, and the struct test type. Function function test. Parameter rule, parameter element. Declaration prop, declaration prop. These are from the test type, I believe. Function func, dec a. Huh? Hmm? That's not right. That is not right at all. And I understand what's happening. Again, the actual... This is so bad. The actual function declaration doesn't have the name of the function and all that information. All that actual semantic information that goes into doing that is in a func sign. So it goes inside of its table, not in the previous one. So that is kind of not supposed to be that way. Rewriting malloc that you couldn't finish during story time. Nice, happy to hear that. I've been meaning to like make my malloc not do a syscall every single time for a while. I haven't done that yet. Because it really shouldn't have to do that. It's literally just a matter of moving code around, pretty sure. It's not super complex. God, that is a problem. It might just be that the easiest thing for me to do is to put this in here. That might just be the easiest thing for me to do in this case. So otherwise this won't work anymore. Yeah, wait, no, but it's yeah, no, hold on. Why is it in some little thing? Is someone else using it? Yeah, function signature here. Who else is using func sign right now? Oh, well, I see. Well, we can keep the rule and just here make it hard coded, I guess. That's not. Let me see. Okay, we have the interface and the struct, then function and function, parameter and parameter, function and function and function and declaration, parameter, parameter and declaration. It is correct. It is correct. So I might just keep it this way for the time being anyway. There'll be time to make the code prettier later on. Somehow I actually end up doing that. I know it sounds like bullshit. I know it sounds like he'll never fix this. Surprisingly, it takes me a while. It takes me a long time. It'll take me months. I'm not about to lie to you. But I do it. That's commendable, I believe. Now, trying to make it optimized and make it and bring a certain level of complexity. Calling sys calls is slow. Yeah, that's exactly why I was saying that I wanted to refactor my mine. Yeah, mine. I am noticing a mistake here though. There's no way for me to know which one this belongs to, because the symbols, the children are being kept as part of the symbol table itself. That is probably not right, but just in case, I'm going to do a little backup. And say that symbol table child. I hope there's only one child, otherwise I have to introduce even more complexity to this thing, which, oh, no, you're now this symbol requires this one, and this symbol requires this one. No. If only there was a way to do this. But there isn't. Not really. Not quite. There is? Wait, can you just do a forward declaration of a type? I feel like I've tried and that just doesn't work. I copied with option. Oh my god, I'm so not used to this keyboard, Jesus. Is it like this? Yeah, I don't think I've ever figured out the syntax for how to do this, if there is a way to do it. Forward declaration of struct symbol. Must use struct tag, that makes sense. But then can I do it like this? Array has incomplete element type. Well. Type def known type new name. Yeah, but new known type is struct right now, so I mean it works. Till it doesn't. It always complains about incomplete field type. Okay, let me just look it up. C struct forward declaration. It's a very simple question, but this is Google we're talking about. Let me see. You have the same problem as me? Yep, you have the same problem as me. That's beautiful. A struct without a type def often needs to or should be with the keyword struct when used. If I don't have to read Stack Overflow, it's probably for the best. Struct A, which declares itself, kind of. I know how to do that. I'm not seeing forward declarations, though. This is recursive. Use a type def along with the struct name Allows you to use the alias later and omit the struct. However, you still need struct prefix when using a struct type recursively. Yep. Forward declare the type def. Type def struct cc. Oh, okay. That? Forward declare the type def. And you get to use the alias recursively. Oh, no. Omit the struct name and you can't use the struct recursively. Here's an unnamed struct as well, but this time with an instance globally created. I don't think that's the same thing though. I'm having the same problem. Alright, let me see the Stack Overflow answer. Okay, so this person has a struct context and then just struct without the type def, I guess. Forward declaration and the type def. Try changing the forward declaration to this in your code. The type def struct context. It might be more readable if you do add a suffix. Oh, but then... Okay, hold on. Bring that back. Go like this. No. No, we're not. Well, no. There, okay. We tried. Oh, God. Hold on. How do you feel about this, Clang? How do we feel about this, Clanger? Alright, you need the struct without type def and the forward def. I don't think I know what I'm supposed to do right now. They say to use this as a type def, right? Which, okay, right now, must use struct tag and struct tag. Now, this one works. Alright. So, I just declare a struct symbol t. Then I declare a struct symbol table. This is not necessary, is it? Neither is this. Oh, wait. It works. It works like this. No, wait, hold on. Array has incomplete element type. Well, will it compile though? Because, you know, I could have just used a pointer. I hate having to put struct everywhere. Jesus, C can be so pedantic sometimes. What is your problem? Yeah, I'm pretty sure this one I can type def. Struct symbol table as symbol table. How do we feel about that? No member named children instruct. Oh, no, wait, hold on. This has nothing to do with that. This is an actual error. Okay, struct. Okay. Did I do it? No. No, because I'm using an array. So it's easier for me to just... this is no longer needed. All right, is this needed? No. Then I don't need all those ugly structs. I don't even need this technically. Pretty sure. Who's talking? Yeah, the subscript is not right. No, this is a, yeah. Are we good now? I think we're good now. See, syntax can be so weird sometimes. All right, it's the size of a symbol table with the size of a symbol multiplied by 64. And then, don't you feel so comfortable just yet? We're not done. Table, symbol table equal to table plus size of symbol table. Cast that to a symbol t pointer. Genuinely shut the fuck up. All right. Are we happy? Because I'm not, but are you happy, compiler? For my compiler. You seem happy. It seems happy. It compiles. Obviously it doesn't work, but it compiles. It doesn't work because I got rid of most of the code. Mostly, when you create a new table, that table does not get attached to the same table as a child. It gets attached to the symbol as a child. Good. 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 Now, this check becomes a lot easier because we don't have to iterate. Instead, we just do children. Well, I'm doing it wrong. Doing it wrong. If sim child, then you tell us that it has children, and then you debug the children with sim child. There we go. Hey, is it correct though? Is it correct though? Hold on, let's find out. You know what? Hold on. I do have a little trick for this. I've used it all over the code here. No. Oh. You don't have a reference to indent by. I'm pretty sure that's just a macro. So weird that it shows it as a. Oh yeah, because It just defaults to int in C, because if a function doesn't exist, it's just like, yeah, it must be an integer. Good enough. Just compile the whole damn thing anyway. Why would you do that? No, it's common.h. The mysteries of C. Okay, we have what looks like the table that I was looking for. So actually, I don't need to print this shit. And then there we have it. There we have it. Correct. With the tiny problem that I have to hard code which symbols generate a new table. I don't have a beautiful way of deciding that. And even if I did have a way to decide that in the rule generator, I would need, I'm again kicking the can up the road to the rule generator instead of to the semantic analyzer. So it's not exactly the lesser of two evils, it's just the same evil, kind of. But okay. Now I can traverse this symbol table. Cool. Okay, we got what we wanted. I can traverse this symbol table, right? And be like, hey, listen, I'm being told that my parent is an interface called hello. All right, do you know anything about this? Yes, I have an interface called hello. And it has a function called func and a function called test. And you need to conform to them. You need to have them. Also, these functions have parameters. Parameters such as a rule and elem, an integer and a token. So you need to conform to them as well. And then I can check, okay, I have a function called func. It has a parameter, int, rule, token, elem. It also has my own internal declaration of an integer called a, but that's none of your business. And I also have a function called test. I also have a function called helper and a couple declarations of properties, but that's none of your business. And just like that, we have symbols. I think we're good. But now it's the matter of how do we fetch this information? Again, I'm not even necessarily interested in this first version of it to do a whole lot of semantic analysis. Like I said, there is another aspect of semantic analysis, which is to check the correctness. Whereas here I'm just fetching information. Whether it's correct or not, GCC will tell me. That's none of my compiler's business, essentially. Yeah, I just want you to tell me what functions are part of this interface so I can make my vtable. Is that what it's called? Vtable? Well, my function pointer table, essentially. That's all the information that I want from you. I don't care if it actually is real or not. It will create a compiler error for GCC if it isn't. But that's good enough for me for now. I'm not doing any type of type checking. I'm hard coding all the types. They have to be the same types as C. Like I said, correctness is an entirely different aspect, which for now I'm ignoring. But probably after I'm done with this will be the next thing. It's probably sometime this weekend. But tomorrow I do want to do something new. I do want to do probably the 3D render, if I'm completely honest. If not tomorrow, then Sunday. But 3D render is happening either tomorrow or Sunday. But yeah, the correctness thing is important, but that's good enough for me. Either way, I will need to fetch a symbol of a specific type and of a specific name when relevant. So we can just return a symbol table. That's very simple code relative to this one pretty much. Find symbol. I already have a find symbol function, which right now just returns a boolean. So I'll change this one's name to symbol exists. In reality, this one will be replaced by that one. But to not refactor all of my code at once, I'm just keeping it there. Again, I'm not doing any of that correctness stuff, so if I did, I have to define a bunch of keywords, their meanings, a bunch of types that are used that are defined externally, but used internally. It's kind of a mess, so I'm not super interested in that right now. Okay. I'm gonna keep the to-do here. Find symbol. Symbol table s equal to this. If s, return s. No need to mess with the indentation in here. That was just for testing purposes. And if we get to the end of this and we haven't actually found our symbol, we return a 0. Then find symbol needs to decide the symbol's type, which is semrule, and its name. So semrule type token or slice? Should be slice technically. Should be slice, writes token. Beautiful, you'll have to see it. Which get passed down directly. And we do if sim dot sim type equals to type, and string slices equal name. I should probably store the symbols as tokens as string tables directly. Just stop relying so much on tokens at this stage. Even though both are just pointers to the type, it's not like it's doing anything revolutionary here. Symbol name case insensitive. No. We could make it case insensitive, I guess. Wait, why am I returning a symbol table? I should be returning a symbol. So I guess here, just keep pointer to it. Then we return the symbol. Okay. And this function needs to be declared before this function. And then this function needs to call return find symbol in tablet global type name. Cool. And both of these actually need to be declared not all the way down here, but alongside with the global symbol table. They need to be declared above this function, because like I said, they will replace the symbol exists function. Because when you get a symbol, when you realize that a symbol does exist, you don't just go like, oh cool, it exists. You fetch its type information, so then you can do some type checking as well. So that will come useful again once I do the next part of this. Cool. Okay, semantic analyzer, we're good? No, we're not. Because on line 116, I forgot that sim is now a pointer. Wait, what? Oh. No, that's not it. I forgot that it's now a slice for the name. Okay, and it still generates the same table as before. Cool. But when it comes to the code generation, which I'm hoping hasn't changed, it's just gotten smaller, of course, and it added a new line. Amazing. Yeah, it has all the information. It has a bunch of missing stuff as well because I deleted half the code. For the last thing for today, we're gonna actually generate this table over here, which right now we're filling this part in and this part in, but we need to fill this part in. So I will do that after the ad break. So I'll be back in 3 minutes. Okay, last part of compiling the compiler. Nah, that's not it. We're nowhere near close to that yet. We have a little bit of self-hosting, a little bit. Just a bit. With a fallback. Okay, so I'm now able to fetch symbol information whenever I need it. And this print, parent conformance here, requires semantic analysis. Well, now we have that, so we can replace it. Okay, so all of this shit can go. But I will keep that there because I will need these eventually. But essentially, what do I need to do? Again, I'm not actually checking for correctness. So that makes it a lot easier for me. Although checking for correctness shouldn't be done in the code generator, it should be done in the semantic analyzer. So I'll do it there. But, oh, another thing, I'm not keeping track of parents, funnily enough. Not in the semantic analyzer. As in, on a semantic sense, test type doesn't know that it inherits from hello at semantic time. So maybe for the last thing I'll do that, but even right now it's not necessary because in terms of code generation, it actually knows that. It has this code parent. Right? So we need to get the symbol. No. It's a little bit more complicated than that. Because these fuck-ass symbol declarations need to be in the header. All right. And then the code generator needs to include that header. As to why I scrolled all the way up manually, I have no idea. Is this where I was? No. This is where I was. Okay. So here I need to get the symbol parent sim using the find symbol function that I did not expose. So this. Also, we're not doing any scope checking for the time being. As in, you can technically have nested structures. That's technically a thing that no, not quite. But you can declare a structure inside a function and then use it outside of that function. Then again, don't do that. The compiler won't stop you, but I'm stopping you. Don't do that. Okay. We're looking for an interface named token to slice code parent. If we don't have it, then that is an error. God, I love typing in this keyboard. I'm still shitty at it, but hey, maybe I can learn to type properly. And we just return, we don't emit any code. Any code that we have emitted so far is probably wrong. Should have done better semantic analysis. Actually, you know what? Should have done better semantic analysis. SMH. Alright, simple, right? What do we do instead if we do find it? If we do find it, we need to go through its children and we need to use them. Wait, hold on. Might as well do this. If it doesn't have a child, that's kind of an issue, right? So table equal to parent sim child. And we just go through it. And I just realized the code that I erased, part of it was actually useful. This pretty much was useful. The part that I needed to get rid of was the actual functions. So hold up. All right. Let's just do an emit. Return v with that. No new line, actually. Well, no, this is not great. What is it supposed to look like? Is it supposed to have indentation here? Yes. So you're supposed to return and open a bracket, increase the indentation, then emit a new line, put the pointer on it, emit a new line. Oh, we'll emit the new line as we emit each child, otherwise that's gonna be a dumb. For int I equals 0, I smaller than table, symbol count, I plus plus. Then just to wrap everything up, we need to decrease the indentation, emit a final new line, and emit this. And I believe do the same thing again. It's this. And this one's already being emitted, so oh wait, hold on. Yes, also yes. Okay. So, what does it look like if I run this right now? Corrupted double linked list. Brother, I'm not using a single linked list, let alone double linked list. I am flabbergasted by this error. Except I'm not. I put a whole bunch of format strings without their formats here. So I kind of get it. I think it just picked a string at random to print. What's the name? How do you get that code name? And every day I find a better way to make my code just spectacularly fail. Honestly, I'm proud of that. Yeah, half the code is missing here. But return hello with a pointer, dialog type test type, this and that. Yep. It's just kind of doing more indentations than it should. Yeah, you're supposed to emit a constant of the opening bracket, right? Because the header emits a thingy here. You're supposed to increase the indentation, otherwise it fails. You're supposed to emit a new line in which you will return. Okay, so now at least it makes a little bit more sense. Call to undefined function dialog, don't worry about that. Expected. Oh, wait. Right. There's supposed to be a semicolon there. Okay, that's good. Now we need to actually emit the symbols. How do we know? Well, based on if the symbol if sim dot name dot length and sim dot sim type equal to sem rule func, then we need to emit what's that code look like? The name equal token to slice dot name, this thing. Emit v equals v underscore v comma beautiful. Yeah, it's actually token to slice code parent. No, not code. Oh, it should be the function name. This is code name, which is used as a prefix to tell you which function points to the generic function. The generic function is given to us by the symbol. So sim name length, and the same thing is done here. Am I printing the length? I'm tired. I'm tired as hell. It does nothing. Wait. It does nothing. Oh no, there it is. Okay. I'm just not emitting a new line. And I forgot the period at the beginning. But func equal test type func and test equal test type test. Correct. Just the formatting is a little bit iffy. You gotta emit a new line before you do any of this. A boom. Classes in C. Once again. Properly, this time. The C++ way. I read that C++. Oh god. We're back at C++. No. But it's kind of the only way to make it extensible, even for like dynamic libraries and whatnot, I guess. Someone suggested a static array where you index it by this, and then you get the function pointer globally instead of per instance. But I don't think so. Typical employee? Did you get a job? What happened with that name? Why did it change? I don't think an individual should give up on coding unless they don't want to do it. So, if they don't want to do it. Okay. I've done it. Classes in C. Once more. I'm saying that like I didn't already do it. Alright, the question is, did it break any of my other code? And this is specifically why I used to have output.c and output.h get ignored because they're not really useful. They're already ignored by the build process, but I was also ignoring them from Git. But by checking their Git difference, it helps me see what changed. Segmentation fault. Yay. Job since 2 months, but I'm no longer a hard worker. I just want money. Oh, right. That makes sense. Curious. The semantic analyzer is crashing on me, I think. I'm not sure. Yep, yeah, yep. The debugger is crashing on me, funnily enough. Why? Yeah, probably because of that. Huh? Oh, wait, I need to change all of these. No, it still crashes. That's interesting. It doesn't look like it has 64 entries. Right, so what is it exactly? It's main, which declares a y, x, z, and I. Alright, quick question. Does it happen if I just don't debug the table? Doesn't seem like it does. And there you go. I can see that all my output is unchanged except for the function that wasn't there before. And the indentation here is iffy. But the functions that were not being generated, the bug that I fixed earlier, and a million, billion, trillion new spaces here. But they're okay. Again, uh, the idea is I don't change this code at all. My my code generator should change it, and I should look at this and be like, is it correct? For example, if right now I'm doing something on the interface generator and this print function changes, I'm like, okay, I broke something. But right now, this file, which I believe contains most of the syntax of my program, doesn't really have that problem. So everything looks good. I mean, most of the syntax of my language. Okay. I'm surprised that the debug function is crashing, though. It's kind of doing the same thing that the other function is doing, and the other function is not crashing. I'm a little bit surprised by that. It's right. Pretty much just doing the same thing here, right? Int I0, table count I++. I'm getting the symbol as the address of the table symbol table I. I don't think this is... Oh, well, it might be. It might be that the only reason it doesn't crash is because this one has an early return. But anyway, if I have a symbol name and a child, then I just get the symbol from there. And if I found it, I return, otherwise I continue looking. Whereas here I do the same thing. Yeah, I do wonder if the early return is the reason why this one isn't crashing. Yep. All right. GDB. No. X run cred.elf, right? Find symbol in table. Thank you, that's so incredibly helpful. The function that I already knew was the one that was causing the crash is the one that's causing the crash. What do you know? You're so helpful. No line number info. Oh, go fuck yourself, bro. I'm not compiling with G, am I? Gee, I am not. All right, let me see if I can. Um, there is technically a way to pass a raw argument, which I'm pretty sure is done by like passing it as a linker flag, kind of. Which is kind of dumb, but yeah, that works, I guess. Since I haven't actually created a way to pass raw flags to the compiler, all of them are D for preprocessor or L or something like that. There is a way to pass flags to the compiler, but I think it's yeah, like this, linker flags. It's linker flags for whatever reason, because they don't have anything appended to them, because not all of them have the WL, so I don't automatically append it. Okay, that's the function that I need. Wait, first I need to regenerate. What do you mean there's a syntax error on line 17? You're a syntax error on line 17. God damn it. My compiler that I'm using to compile that is out of date. Classic. But this is why I created a fallback. If you just type C, it compiles the build.c directly without passing through this, so you're able to... Did it just fix itself? Did it just fucking fix itself? No, right? Oh yeah, I brought this back. Okay, thank God. Alright, there we go. GDB, do your thing. Are you serious? Wait, why are some symbols empty? I know the fix, but I'm a little bit confused by this. So the debugger can tell me that there are empty symbols. And just return. So that can be useful. It's still seg faults. No, string slice? I don't understand. String slice is a structure. It just contains some a pointer to a string and where it ends, pretty much. I think that's it. I don't think it even contains anything else beyond that point. So we're checking that symbol is true, and that it exists essentially, and that it has a name length. Why is that seg faulting? There is a symbol, And that looks like garbage. That's a garbage value. I see. All right. Debugger. Tell me where. I declare y, x, z, and I. Y, x, z, and then I. I'm not really declaring any more symbols besides these labels here. Spent the whole afternoon trying to find the bug in your advent of code solution. Oh no. Did you find it though? You're saying worth it. I'm assuming it was. You found it. Alright, I'm actually gonna get rid of loops, by the way, which I don't even want to support them. Wouldn't be surprised if they're the ones causing the issue. They're not. They are not. Found the multiple bugs. Ooh. I was so close to being done. So close to greatness. Yeah, no, eventually you find the bugs. Main, what symbols do you declare? You declare a y, x, z, I, x, y. That's it. Those are the only symbols it declares. It doesn't even declare anymore after that. I am so confused by this. But should I just... Now let me try a bit longer because I do have this. That should give me a little bit of information. I'm completely sure it will make a better programmer. Debugging helps, honestly. It teaches you a lot. Okay. Int y, int x, int z, int y, int I. I don't understand what the fuck you're trying to read here. Alright, can you just tell me how many children this table has? This is so weird. Child symbol count. Alright, tell me that. Well, I see that it has 147 children. So, yeah. And then it actually prints 4 correctly. Alright, so it's memory corruption. Fucking shocking. I know. Where's the function where I allocate a new table? Okay, here. A table is made out by allocating a size of a symbol table with a size of a symbol t times 64. I just want to make sure some extra parentheses in here. And then I'm putting the symbol table at um, the table plus the table. So the actual array is after the type. Cool? We cool? We're not cool. Okay, but now the debugger is not crashing anymore. And never prints this. Yes, this just happens. Beautiful. I mean, main should have children, yes. But it shouldn't have this many. Wait, these numbers are all wrong. Has 9 well, no, hold on. They're not super wrong. Because again, there's a bunch of tables being generated there that aren't actually real. Oh, so, okay, I get it. Shit. When a symbol is being generated and it doesn't have a length, again, which is, like I said, a big fucking hack, then you have a bunch of empty symbols, but they're kind of overflowing the table. I guess the solution for now is to make this a little bigger. Well, no, the solution really is to make it a expandable array. But, alright, it doesn't crash anymore. And it outputs properly. And it works. Whew. That was not fun. That was not fun in the slightest. Alright. Oh well. I put to-dos in the areas where I realized that there's problems. Yeah, it's sometimes that's just the best you can do. All right. So, wait, now that my compiler works, one last thing I need to do is I need to not debug the table, right? Which already clear that. I need to get rid of this, clear that, and get rid of most of those logs. Cool. Then I can publish my compiler, and now I should be able to read C. Okay, cool. So the new version of the compiler fixes the issue with the build system, which essentially was just because it didn't recognize what this meant. Now it does, so it's fine. Okay, alright, so that's gonna be the end of the stream. Because I am tired as hell. But I did what I wanted to do. And the thing about being able to do this is semantic analysis like this. Even if, again, I'm not checking that everything is correct, but I am checking that it... well, I am generating code. And if it just so happens that the code you generate is nonsensical, GCC will catch that, and eventually I'll make some proper semantic analyzer. Or I'll expand my semantic analyzer a little bit. Then most likely the compiler is gonna go back for a bit to being just a lot of repetitive work, like I said. So let me just proper symbol tables, and then what's the other thing? Codegen struct parent conformance. Here we go. Okay. Yeah, so most of the compiler work from now on is going to be a little bit more repetitive, like it has been during the week, but then again, I haven't streamed it. But yeah, just a lot of adding new rules, maybe adding new semantic rules and generating code for them, cleaning up the code generator, fixing bugs here and there, maybe a couple of the to-dos that I need to do. The other kind of, by Penguin, important thing that I did say I want to do on stream for it is type checking. No, is that it? Yeah, type checking. I forgot. Because again, my language right now, if I want to declare any types or use any types like an integer, a string, or anything like that, I have to use the exact same types that C uses. And for a string, this is a problem because C uses char star, so char pointer. Where's that? Seriously, I opened like the one file that doesn't use it. Well, anyway, char pointer. You can picture it. And I don't use star at all in my language, and I don't want to do that. So instead, I would want to call that C literal or something like that. I do want to have a dedicated type for it because it is very important if I'm going to have C interoperability to have C strings, which are zero terminated, null terminated, that's what it's called. But I want my language to mostly use string slices, which is, I'm probably going to call them strings. I currently have a string type, which is also null terminated, but I'm probably going to phase it out in favor of string slices. I am kind of doing that already. But yeah, so I'm going to need to do a little bit of that type translation, type, very, very, very simple type checking. Then I'm going to have to expand it a lot more after that. But yeah, that's probably the next thing that I'm going to do on the compiler, like short term. Maybe this weekend, maybe next one. But, like I said, I want to do something a little different next time. Didn't I tell you to open a file? What happened? What happened? Oh, did it? Okay, it just took forever. Alright. Oh, it opened it here for whatever. Oh, because it was already open. Okay. It's usually I highlight it with Markdown. Right, so this is done. Or even B. There we go. What do I want to do tomorrow? Most likely. Well, I don't know. If I'm feeling fun, a 3D renderer. If I'm feeling boring, a task management program. Again, just something that helps me like visually keep track of tasks that I'm doing and whatnot. And actually, I feel like this right here is gonna be the initial format of the data. So it's not gonna modify the data directly in the first like prototype of it. I just want to do the visual aspect of it. Yeah, because I feel like building a visual app and I need a task manager. I don't have a problem with keeping my to-dos and tasks in a list. That's kind of how I'm doing it right now. And I don't want to use... I actually straight up said in Discord when I asked, if somebody says Jira, I'm banning them. But also anything similar to Jira, no. And I don't want to use like any bloated note-taking app. So again, I'm just making my own thing. And this is probably going to be the first format for it. All right. Again, if I'm feeling fun tomorrow, it's going to be 3D renderer. If I'm not, it's going to be a task manager. Okay. But that's going to be it for today. Tomorrow's stream is in the afternoon. It starts at 3 p.m. Central European time and 2 p.m. UK time. I'm going to link my Discord Going to link my Twitch. Gonna try to do a raid. I always forget to do that, so I might as well just do that real quick. So, alright, if you're interested, feel free to join. Even though half the people on Twitch left right as I was ending. So, not gonna be a gigantic raid, but hey. Let me see what there is to raid, because I'm not following anyone that's live right now. I always try to go for non-game dev, but that's very difficult. Oh, someone's making a compiler, but it's in French. Compiler, c'est tester. And also it's tagged as game, I think. So at some point there's been games involved. Roblox, game dev, game dev, game dev, game dev. Everything is game dev. All right. We're just going to go with game dev. All right, everybody. I will see you tomorrow. Wait, we're not done yet. If this raid would just go. I don't know why it takes 10 seconds. I'm guessing just so everyone raids at the same time. All right, here we go.